Thank you everybody for joining today's webinar. We are going to go ahead and get started. My name is Amy Bui-Perez with Mphasis Stelligent, and I will be your host today. Before we dive into the presentation, I'm going to cover just a little bit of housekeeping. This webinar is going to be recorded and an on-demand link will be available and shared with you post-webinar. Please feel free to share this link with your colleagues. You can submit any questions you may have in the Q&A box in the lower right-hand corner. And at the end of the webinar, we will try to spend as much time as we can to answer some of your questions. If we do not get to your question during the webinar today, we are happy to follow up via email. And last but not least, if you are on Twitter or LinkedIn, be sure to follow Stelligent for news, resources, and announcements for future webinars and events. Alrighty, let's go ahead and get started. So our webinar today is, the topic is Pipeline Factory, Scaling CI/CD on AWS. Today, joining us, we have Josh DeMuth, Partner Solutions Architect with AWS. Josh is an AWS Partner Solutions Architect who is dedicated to helping organizations throughout their cloud journey. He has experience delivering complex solutions and has a desire to automate everything. Josh is a builder at heart and wants to continuously share his passion for the cloud. Also joining us today is our very own Stelligent's Dante.Martinez, who's our Senior Solutions Architect. Dante is an AWS Certified Solutions Architect with more than 20 years of experience building software, delivery, and operation systems. He brings a true mastery of the DevOps and SRE frameworks, resulting in solutions that lead product, development, and operations teams to the highest success levels. Dante is part of an all-star team here that architects and develops solutions to accelerate, secure, and modernize software delivery and operations. At this time, I'd like to go ahead and hand the mic over to Josh.
Thank you, Amy. We'll be sharing my screen. All right, so good day, everybody. My name is Josh DeMuth. I'm a partner SA at AWS, like Amy was saying, and today I get to talk with you about one of my favorite topics, which is DevOps and CI/CD, infrastructure as code, and some of the services that we have that can help facilitate this. And the way that we kind of structured this today is I'm going to give a refresher on a few concepts first. So I wanted to do a refresher on DevOps, a refresher on CI/CD, and then infrastructure as code. And then I'll dive in and give a high-level overview of the services that can help with this. So to begin, let's do DevOps first. So when I think about DevOps, I always think that it's just not one thing. So I bet that if you asked, maybe 5 or 10 different DevOps practitioners what the definition was, you may get, 5 or 10 different answers. But for this webinar, I'd like to define it as the combination of cultural philosophies, practices, and tools with the overall goal to try to accelerate your ability to deliver applications a lot faster. And the way that we do that is by having, great collaboration across the dev and the ops teams, or hopefully they could be one team, for example, with automation that we'll talk about. That's where CI/CD comes into play, and then of course with the ultimate goal of speed. So if we think historically, like developers and operations teams, they can have competing forces at times. So the developers need speed, and a lot of the reason that is because they're probably getting their their backlog or their features from customers, or maybe from their sales team, for example, that says, look, we have a competitor that is excellent in this area, and we're going to start losing our customers if we don't get these features out. So it's very much customer driven, and the faster that they can create these features, the better. However, if they move extremely quickly without any guardrails, then it can cause instability. That's where the operations team, they're like, well, if we have an unstable system, then all of our customers are going to be upset, and we could lose them all. So there has to be a balance between speed and stability, and that's where DevOps comes in. And one of the mechanisms that a DevOps team could leverage to be able to get this balanced forces is by using CI/CD. So just real quickly, we'll go through a CI/CD refresher. So CI/CD means continuous integration and continuous delivery, and sometimes you'll hear it be called continuous deployment as well, and we'll touch on that shortly. But to describe this topic, I'd like to go through the 5 high-level stages of a software deployment cycle. So we start with the source stage. So this is where your development team would be doing a lot of their work, whether that's in a Git repo, for example. They could make changes that are version controlled, and they could have code reviews before it's allowed to be merged into what could potentially go out to production. But a lot of the feature development and just all the dev work would be done in this source phase. Next is build. So this is where all those changes that were made and you're ready to actually deploy those out, that you would go through a build phase. So this could compile the software. You could do unit tests, maybe some static analysis, and just really packaging it up to for it to be shipped out. And the next is test. So this is where maybe what you built in the previous stage, maybe you put it into an isolated testing environment, and you're able to run your slate of tests, whether they're load tests, security tests, integration tests, your full test suite, you'd be able to run during this phase. And then if everything looks good, then you're ready to deploy. So this is, again, where you get it out into the wild, where the code is now usable for your customers. And this is where maybe some post-production validation happens to see if a rollback is required. Could be done in that stage as well. And then you just have post-production monitoring long term, where you continuously get feedback, and you pass that back to the source stage as needed. If maybe you didn't provision enough capacity, or maybe the new feature is causing issues that you didn't really think were going to happen. So you can get that feedback loop and correct that for the next deployment. So when I look at this, we have these 5 phases, but there's nothing that says that each one of these has to be automated. That you could technically do all these manual. So just because you go through these phases doesn't necessarily mean that you have CI/CD or a pipeline, or that you're necessarily doing DevOps. So the way to start that process would be to implement what we are calling CI/CD, which the CI of that is continuous integration. So this is, as you can see, like the source, build, and test phases. So the idea is that once a code is pushed to the source branch, that would kick off automatic builds. And then after the build, if that's successful, it could kick off automatic testing. And the idea is that after the developers push that code, that they'll get feedback on whether that was integrated with the wider code base successfully or not. And if it's not, then they have to kind of go back and make sure that everything looks good for the next try. And after that, we have continuous delivery. So this would be, okay, your integration to the code base looked good, and it's packaged up, and it's ready to be deployed out. But maybe there's like a manual step that someone wants to approve that the deployment goes out, or maybe somebody needs to go warm up an instance, or just whatever it may be. Maybe there's just a slight manual step in the process before that code is actually deployed out. So that would be continuous delivery. And finally, continuous deployment. This is where there's no manual intervention at all, that you trust the process so much that once that code makes it into the source repo, that as long as all the building and the testing goes successfully, that it will be deployed out into the wild without any manual intervention. So by a virtual show of hands, is there anybody that is actually at this step where they trust that process so much that they feel that their developers could push anything and their process will fail it if they feel like it would cause instability in the system? So it can be really difficult to get to this, but it's also extremely powerful. But it requires a lot of trust in the testing process, and this is where DevOps with the operation team, if they have a say so in what those tests look like, and if the developers have a are required to have a certain level of code coverage, for example, that maybe you could get to that point. All right, so that was a quick refresher on DevOps and CI/CD. Now infrastructure as code. So the idea with infrastructure as code is that everything is code. So code is not just for applications anymore, that all your infrastructure could be code, your pipeline can be code, as Dante will talk about here shortly, configurations, security policies, just anything that goes into making a production workload from infrastructure, security, application, that it can all be code now. And that means that you can have guardrails and deployment processes that check this code to make sure that everything looks good and it's following your standards. One of the tools that we provide for infrastructure as code is called CloudFormation. There's a lot of advancements in this area. So CloudFormation is not the only tool that we have right now, but it's still the most popular. And the idea with CloudFormation is that you would have a template file, and you could effectively code out your infrastructure into this template file, load it to the CloudFormation service, and then it would as long as it's valid, that it would create every resource and instance or service that you have coded out in that file. It would create that for you, and it would handle all the dependencies and relationships and the order of which the services need to be deployed. So it handles all that heavy lifting for you, and you just need to code it out in that file. And then if that's stored in like a code repository, then you can always see the history of when it's changed. And if you're having issues in your environment, you can always go back to that file and make sure that nobody did anything manually, for example. And lastly, in this section, I wanted to introduce you to Service Catalog. So the Service Catalog itself is not infrastructure as code, but it allows you to take a CloudFormation template and create an application. So Dante is going to speak about this a little bit, so I just wanted to give a quick intro into this service. But the idea is that you can take a CloudFormation template and create an application around it that you're allowed, that you could give your departments the ability to consume this application. So if we think of a pipeline as code, then maybe some like your web app team needs a certain type of pipeline, your API team or your microservices team or whatever it may be needs a different type of pipeline that you could use Service Catalog to to only allow the consumption of the pipelines that each group would need. All right, I know that was really fast. We went through a few refreshers, and now I want to talk about some of our AWS developer tools. So first is code commit. So code commit is source control as a service. It's built upon Git. So if you have a Git repo, then you would be able to leverage code commit. And some of the benefits with this is that it's within your account. It's private, so it's not a public Git repo, and it is able to kick off other processes that we'll talk about in a second. And the next is code build. So code build is like continuous integration as a service. It can scale to meet your demand, and it is container based. So you're able to bring like your own runtimes if you want, if you have special builds that wouldn't run on the default code build runtimes. But the idea for code build is this is where your building and your testing happens. So you can build and create artifacts, and then you can test to make sure that everything looks good with your code. And next is code deploy. So this would be the the continuous delivery portion of our CI/CD. So this is where you can get code out into the wild. It's fully managed, it's deployment as a service, and you can deploy to various different targets like EC2 or Fargate or Lambda, and even on premises. And it also allows you to monitor, and there's a few different deployment styles depending on your target. But again, it's a fully managed service, so you don't have to worry about the underlying infrastructure for it. And next is code artifact. So this is a secure, scalable, and cost-effective artifact management. And it works with a lot of our, common package managers that are out there like npm or NuGet or Maven, and this allows you to have a private code artifact repo where, you know, when you're going through your code build job, for example, that it could reach out to code artifact, and let's say that your application has a lot of dependencies that it needs to pull down, and one of them, you know, has a security issue, that you could go into code artifact and remove that, and then any future builds would fail. So it you know, would allow you to like not allow an application to build with that dependency. And finally, code pipeline. So the way I like to think about code pipeline is, you know, how we can string all these other services together. And the way that I want to kind of show you that is with this slide, where you can see, you know, code pipeline is kind of like a wrapper around code commit, code build, and code deploy, along with a lot of other things that are not pictured here. But it allows you to, you know, create a fully managed pipeline. So this is kind of like delivery as a service, and it can, you know, take a change that gets committed to like code commit, for example, and you can tell it like what to do next, like, you know, trigger a code build job, and then after that go to your testing jobs, and then deploy or run CloudFormation from it. So there's a lot of power with code pipeline. But that's what I had today. So again, it was just a quick overview of some of our services and a refresher. And I'd like to hand it over to Dante.Martinez, who is going to talk more about how the Stelligent team has been able to leverage these to build a solution.
Thanks, Josh. So as you can see, AWS has built and provided a great set of services that allow us to very quickly and easily build out full software delivery platforms. And one of the key capabilities they included in that is the ability to define and codify the configuration of those services by using CloudFormation or the service APIs as well. So at Stelligent, we've developed a series of frameworks that take advantage of that ability to codify systems and environments on AWS. So our philosophy has been that DevOps teams should work just like your product teams, right? So they should be designing and developing DevOps products, if you will, that meet the needs of your application, product, or your operations teams inside of IT. So this sets up a model by which your DevOps teams begin defining consumable products for things like AWS accounts, specific AWS infrastructure, CI/CD, which we'll talk about today, but also security controls and even data objects. So your DevOps or your operations teams can focus on standardizing and improving application deployments and operations on AWS, and your application teams can then deploy those vetted products on demand at scale and with confidence that those environments are reliable, resilient, and secure as well. So today we're going to take a look at the CI/CD piece of this model, but first I want to talk about why building an agile CI/CD capability has become increasingly important. All right, so here we have a very simple example of a classical monolithic architecture, which I hope most of you are moving away from, but, you know, nice and simple, right? So of course there were many negatives to that approach, chief among them a complete lack of agility in your software development process. But one positive was that build, test, deploy operations had kind of limited demands as well. So you had pretty low overhead in terms of your software delivery processes. So a very simplistic example here, but you know, we can show an entire application in basically just 3 layers. Which would represent typically 3 code bases as well, if you will. And that would equate to a very limited number of CI/CD pipelines, right? And over the lifetime of the application, there would probably also be a very limited number of changes you'd make to your build, test, and deploy process. Because in most cases, once you set the build and test process up, you would have minimal changes to them over the lifetime of that application. Now, under a more modern microservices architecture, each component of your application represents a separate code base, right? You should keep those code bases discrete, so to speak. And this requires use of separate CI/CD pipeline for each component of that application. So here we have a couple of examples of two fairly simple applications under a microservices architecture, right? And each one has a UI or API interface component, and then 4 or more supporting microservice components as well. So even with just a couple of simple applications, we already need to create 10 or 12 CI/CD pipelines just to allow for discrete development and deployment of our microservices, right? And that's key to what gives you the agility inside of the microservices framework, because we can develop and test and deploy each of these microservices independently from each other. And as you can quickly see, this starts to become a large source of overhead, right? So as you begin developing more and more applications, you may suddenly find yourself creating, managing, and deploying dozens or potentially hundreds of CI/CD pipelines for your software delivery operations. So here we've got just a handful of applications, and even with relatively simple demands, we've gotten to a count of 52 CI/CD pipelines. And I'm not even considering what pipelines are needed for the data objects that back these applications. So in a large enterprise, you can imagine with many applications and with more complex applications that have higher counts of particular microservices, you could very quickly find yourself supporting the need for hundreds or even thousands of CI/CD pipelines. So at that level of scale, you will start to run into quite a few challenges, right? So first, how do you empower your application and product teams to deploy CI/CD on demand while ensuring enterprise standards are met? So if you've configured CI/CD manually, you can imagine that with each new code base, your developer will spend a couple of hours to create an initial pipeline, and could spend several more hours or even potentially days iterating and troubleshooting that pipeline until they get it working how they need to. So that's valuable time that they're not developing application code, right? And as with any ad hoc or manual process, it's prone to error. So did they include all the enterprise standards for quality and security? Did they include all of the appropriate tests and event handling for failed builds or tests? And our next set of challenges, how do you set enterprise standards for building, testing, and deploying applications without becoming a bottleneck? And how do you incorporate quality and security controls? So under our manual methods, you might imagine the application team has created their initial pipeline, and they might then pass that off to your DevOps team or a security team to review that configuration and probably check it against a checklist that they have. So that could take hours or even days for those teams to conduct an ad hoc examination of those pipelines. And while checklists can help, they are also still prone to human error. So without a dedicated or defined workflow, without a defined codified set of standards, and without automation to enforce those standards, you're going to struggle to scale CI/CD at any acceptable level of quality and security. And you're going to cost valuable time for both your development and your DevOps teams. So we start to address those challenges with the pipeline factory model. So here we can begin to define and then codify standards for our CI/CD pipeline in the form of CloudFormation templates and associated configuration files for builds, testing, and deployment. So we can bundle all of this as a pipeline product, which is a single code base for a particular CI/CD pattern. DevOps teams can define and codify enterprise standards for builds, testing, and deployments. And the pipeline factory ensures that any deployed pipelines include those defined standards. So this includes any required quality and security controls. And the automation eliminates errors from ad hoc configuration and ensures that your pipelines are enforcing those quality standards for the full application delivery lifecycle. And by vetting and building CI/CD pipelines as products and making those available for consumption in AWS Service Catalog, you bring the capability to scale CI/CD deployment for enterprise demands. So application and development teams can simply select from a catalog of ready to deploy CI/CD pipelines and can deploy those within minutes. And they can have confidence that those pipelines will deploy their software products with high levels of quality. So how do you start to build your pipeline products? Well, the first step is to begin identifying patterns inside of your CI/CD pipeline requirements. So here we have a couple of example applications using a microservices architecture. And you can see on our first application, all of our services are built on the Spring Boot framework. So we should be able to have a common set of build, package, and deployment processes common to the Spring Boot framework. So we can build a common pipeline pattern around those common requirements. So our second application should also be able to use a common set of processes around build, package, and deploy for the Node.js framework. Now, our first application, we can also identify a common test suite for the supporting microservices. As they're all Spring Boot services, they should have a common set of test tooling. And we can handle differentiations in the test requirements by parameterizing those configuration elements in the CI/CD pipeline. So the order microservice might flag a specific set of unit tests, while the ship microservice flags a second set of specific unit tests particular to those individual microservices. Or we could flag particular services to execute an entire set of integration tests, while others may only have a need to execute a smaller subset of those integration tests. So we can define those differentiations between the service requirements as parameters, and we can pass those into the pipeline when we execute it. And finally, we can identify a common pattern for deployment for our second application, right? So perhaps in this case, it's a Node.js framework. We're deploying these all as Lambda functions, and we're front-ending them by an API gateway. So you can imagine that you might have common configuration requirements for those Lambda functions and common configuration requirements for the API gateway in front of them as well, or they might even share a particular gateway as well. So again, we can define all those as a common configuration pattern for our pipeline product. All right, so having identified those common pipeline patterns, we can begin to assemble our pipeline product itself. So to keep it simple here, I've got just a minimally viable pipeline product, right? So including kind of the four basic stages of any CI/CD pipeline, right? So source, build, test, and deploy. And we can configure each of these stages with CloudFormation and related build and test spec files. And then we can bundle all of these stages inside of CodePipeline also as a CloudFormation template. So these templates and the related spec files exist as a single code base for your pipeline product, and we store those inside of AWS Code Commit. So this allows you to version control your pipeline product so that as you make improvements or iterate on your pipeline product, so perhaps you've got new testing schemas you need to add or replace or modify, you can do that and manage the code base inside of Code Commit using your typical Git or Git flow processes and workflows. All right, so let's take a look at some of these stages in a little more detail, and we can take a look at some of the configuration elements that go into each one to build our pipeline product. So our first stage, the source stage, here we're working with the AWS Code Commit service, right? So here you can configure your repository settings, so things like naming and tagging schemas. You can define access controls, so you can define who can access code, what they can do with that code, or what services can access that code for your deployments as well. You can also configure things related to your workflow, right? So depending on your branching strategy or workflows, you can configure how that works inside of Code Commit. And for our build stage, right, so we're using AWS Code Build. So here we're going to define how our code base is built and packaged. So at this stage, we're using CloudFormation to configure the AWS Code Build service itself. So we're going to define things like how it manages artifacts, how it's going to name particular artifacts. We're going to define the AWS Code Build project itself. And then inside of that project, we're typically going to have a build spec YAML file, and that's going to define the actual build process itself. And you're actually, Code Build is essentially sort of this lightweight container, so you can actually pull in any number of external build tools or packaging tools, and you can define how how they're executed, similar to you would a containerized application, right? So it's very flexible in how you can build, and have yet to come across a framework that I couldn't get a build process to work well inside of code build. So for our test stage, interesting enough, right? There's no particular native testing tool in AWS, but we do have a couple of options that allow us to run external testing tooling, right? So for a lightweight testing, you can often invoke a Lambda function if you've got a real quick or small testing tool that you need to execute. But in most cases, we'll actually utilize AWS code build because again, it's essentially a lightweight container, and we can pretty much make it execute anything that we can pull into that container, right? So that gives us the ability to execute a temporary testing environment. So again, here we'll use CloudFormation to do the actual code build configuration. So we'll build a project in there, but then we can actually pull in build spec YAML to execute our testing tools, and that YAML file can actually pull in configuration elements for your external testing tools. So here we're just a couple of kind of common tools, Appium and Cucumber. So you can see we can actually configure the Appium tests inside of its DSL language, and Cucumber has kind of this more pseudocode type language, but it doesn't matter really what the DSL or language that those testing tools are using, because we can simply import those tooling, and we can import their configuration files for execution inside of the test stage. And the last stage, right, so the deployment stage. So here we're using the AWS code deploy service. And here, we'll use CloudFormation to define the type of deployment, right? So whether it's a more traditional deployment to EC2, a container-based deployment to AWS Fargate, or a serverless package, we can deploy to Lambda, right? So there's a number of options inside of code deploy for how you package and deploy those applications. And you can also configure things like orchestration requirements. If you're running a container-based application, you can configure how API gateway is configured if you're using more of a serverless type configuration, or you can even configure how scaling is done if you're using a more traditional deployment to EC2. And again, that's all done through a CloudFormation template. So finally, we put this all together as our pipeline product. Again, this just represents a single deployable code base consisting of the CloudFormation templates themselves for the AWS services that we're using, and the associated build and test configuration files needed by code build to execute our build processes or our external testing tools. And again, remember, we can parameterize this pipeline product to allow for flexibility in its use. So you might have common build processes, but you can also build in exceptions or niche use cases, if you will, inside of those build processes. And the same for the testing, right? Because you may have an entire portfolio of unit or integration tests, so you can actually define those as parameters and allow the developer or app teams to select which testing stages they need to execute inside their pipeline. All right, so finally, having defined our pipeline product, let's remember that we need to treat this code base just like we would any other set of code, right? So this does get a bit meta because we now have a pipeline of pipelines, right? And that's exactly what we want, because we'd like to package, test, validate, and then deploy our pipeline products just as we would any other software product. So we've developed some automation and tooling around validating pipeline product, and we've developed a workflow that allows your DevOps teams to create and publish pipeline products at scale. So we pull in our pipeline product from AWS Code Commit, and with each iteration of our pipeline product, our pipeline will execute automatically to, again, validate and then publish updates to our pipeline product. So first, we need to validate that our pipeline product meets any globally defined standards. Now, this stage of the pipeline will allow you to define global standards for all your CI/CD pipelines. So if you've got particular controls that are universal or particular sets of standards for your CI/CD pipeline, this is how you would define and then enforce those mechanisms. So for example, you might want to define a control for CI/CD pipeline access and execution to restrict who can access and deploy specific code bases, who can access and control specific code pipeline instantiations, or you might define a set of controls that ensure any pipelines include specific testing types or stages. So, simple example would be I have a requirement that any pipeline includes at minimal a set of unit tests and at minimal a set of integration tests so that I can ensure the quality of the code that's going through the pipeline. And then finally, you can also define and ensure that any deployment configurations meet your security standards. So we can bundle in a set of security controls and ensure that those pipelines are applying and enforcing those controls as well. So how do we ensure those standards are enforced? So Stelligent has developed an open source tool called CFN-NAG, which conducts static analysis of CloudFormation templates that define your pipeline products. So using this tool, you can automatically ensure that those templates meet the defined standards. And then having validated our template, we can then take testing to the next level by including an operational validation stage. So here, we'll actually deploy our CI/CD pipeline into a temporary validation environment, and we can actually execute the code pipeline instantiation and validate that it deploys in the expected manner, or that build and test stages give us the expected output. So if any of those stages fail, we get very fast feedback to our DevOps teams, and they can correct any pipeline product configuration based on feedback from those errors, right? And if everything checks out right and we're happy with the pipeline product, we can then deploy that, or publish it in this case, out to AWS Service Catalog. So the pipeline will handle packaging that up for you and then pushing that out to AWS Service Catalog for consumption. All right, so finally, we've published our pipeline product, and the key service for consumption of that product, right, is AWS Service Catalog, which, as Josh mentioned earlier, right, that allows us to take that CloudFormation template and the associated configuration files as well, and we can actually publish that as an application, if you will, inside of AWS Service Catalog for consumption by our app and dev teams. So those teams can then simply come in, browse into the catalog, and they can deploy on demand and within minutes. So AWS Service Catalog also includes the ability to pass parameters as well. So we can actually include a set of options that allow our developers to walk through and select criteria for their particular pipeline. So they can select things like particular build processes or particular testing processes as well. And that allows them to select proper build test and deployment parameters that they need for their application. All right, so end results, right? So having put all this together, we get some great features out of it, right? So product and development teams can deploy CI/CD pipelines on demand and within minutes, right? Your app and dev teams no longer need to deploy or create the CI/CD pipelines themselves in an ad hoc manner or manually. They can simply browse the service catalog, select the pipeline pattern they need. They can select a few options for their build or testing needs, and they can deploy that pipeline within minutes. And that allows them to focus then on writing code for your application or your product instead of spending time managing CI/CD, right? Next, right, so product and dev teams have confidence in that CI/CD pipeline or configured enterprise standards for build, test, and deploy, right? They don't need to run a checklist. They don't need to develop a pipeline and then run that by a DevOps team or operations team to validate that that pipeline is correct, right? They can have confidence that that pipeline has been vetted, tested, and it's ready for production use. And then finally, the DevOps teams themselves, right? They gain the capability to define and implement quality, process, and workflow standards. And they also gain the capability to define security and governance controls, and the capability and the confidence that those are enforced by the pipeline product itself. So they can do this ahead of time. They can do this and vet them ahead of time, and they can publish those for consumption by your app and dev teams. And all of these features, right, and capabilities, so they allow you to scale very quickly, right? Because your DevOps teams and your app teams can then cooperate on iterating and improving those CI/CD pipelines over time. And over time, you'll build a nice library of pipeline products and pipeline patterns that will meet a good coverage level for most of your CI/CD needs and processes. And in terms of overhead, right, this reduces your overhead and lets you spend time focusing on developing your product and your applications instead. All right, so thanks for joining us today. I'm happy to present the Pipeline Factory framework to you. And with that, I will probably hand it over back to Amy.